Okay, so let's talk about one last thing before we do a problem, the difference between statistical significance and practical significance. So when a large sample is used in a hypothesis test, the result could be statistically significant even though the difference between the sample statistic and mean stated in the null hypothesis has no practical significance. So even though we said that it was statistically significant, the weight in quarters average of the state quarters was 5.7 grams versus 5.67. It just happened that the standard deviation was so small that it made it seem like, oh, this is really unusual. But is anyone really going to be able to tell the difference between 5.67 grams and 5.7 grams in terms of weight? Probably not. So practical significance refers to the idea that while small differences between the statistic and parameter stated in the null hypothesis may be statistically significant, the difference may not be large enough to cause any concern or be considered important. So let's look at an example. In 2003, the average age of a mother at the time of her first childbirth was 25.2. To determine if the average age has increased, a random sample of 1,200 mothers is taken and is found to have a sample mean age of 25.5 with standard deviation of 4.8. Determine whether or not the mean age has increased using a significance level of alpha equals 0.05 using the p-value approach. So our expected mu value should be the same as previous mu values. So that would be that the age is still 25.2. They also want to test if it could possibly be bigger than 25.2. So are people having children later in life at the alpha equals 0.05 significance level. So let's go to the next page and calculate our standard deviation and then our test statistic. Now we know S is 4.8 according to the problem. We know our N is 1,200. So that means S over the square root of N is 4.8 over the square root of 1,200, which is 0.1386. So my test statistic is the value from our sample, which was 25.5, minus the 25.2 expected value over 0.1386, which is equal to 2.17. So we have a test statistic for 2.17. The largest number of degrees of freedom that we can see for our 1199 is 1,000. And we're looking for 2.17. Now if I look at the t-table for degrees of freedom 1,000, look for 2.17. It's less than 2.33, but greater than 1.962. And those correspond to, that means our p-value is between 0.025 and 0.01. Well, what does that mean? Is our p less than 0.05? Yes, because here's our t-score of 2.17. It's saying this area to the right is somewhere between 0.01 and 0.025. What does that mean? We reject H0. That means there is sufficient evidence to conclude at the 0.05 significance level to conclude that the mean age of a mother at time of her first childbirth is greater than 25.2. Okay, so what does that mean? Well, we found it in our sample to be 25.5 versus 25.2. However, 3/10 of a year is a little over 3 months. Is there a really big statistical significance between being about 2 months or 3 months into your 25th year of life versus 6 months into your 25th year of life? Not really. Most of those people would probably just consider themselves 25 either way, who are at the average point. So one thing about large sample sizes is large sample sizes can lead to statistically significant results while the difference between the statistic and the parameter is not enough to be considered practically significant. So why is that? So let's look back at this problem. Remember that the sample size is something we end up dividing by. So if we take a really big sample size and we divide by it, we're taking a number and dividing it by a relatively large number. The result of that is our standard deviation for our sample ends up really, really small. Small enough that 0.3 of a year was enough to get a t-score of over 2. So this is why large samples can sometimes create this problem where statistically significant results aren't actually practically significant. And this is the end of chapter 10. Even though normally stuff that goes up on Tuesday is due Wednesday, because the test doesn't close until tomorrow, I'm going to move all of the chapter 10 stuff to do Friday so you guys have time to finish your test and not feel rushed. Tomorrow we will do all of chapter 4, 4.1 and 4.2, and that will be the last lecture that we have. And so that's it for now. Another one up tomorrow.